Hi children, welcome to RK Maths. Myself I am Ramakrishna, SA Maths ZP Challapeta. Today in this video we are going to learn about the chapter 2 sets from SCAT Maths 10th class AP Andhra Pradesh. This chapter contains 4 exercises. Now in this video we are going to learn exercise 2.1 which depend upon 3 or more concepts, that is sets introduction, definition of a sets, that means what is well defined, and third one is naming of sets, and fourth one is types of sets, that is form of sets. Okay, let's go to the introduction. Coming to introduction, I give you 5 examples here. Look at carefully and observe and tell me the common property in that collection. Coming to example 1, it is a collection of mathematicians, some mathematicians: Euclid, Pythagoras, Gauss, Leibniz, Aryabhatta, Bhaskar. And for example 2 is AIOU, or the vowel letters from English alphabet. And example 3 is a collection of happy, sad, angry, anxious, joyful, confused. Is the collection of feelings of a man. Okay, let you say what is 4 and 5. 4 is also a collection of 5 games, and fifth one is the 1, 3, 5, 7, 9, so on. So it is the collection of unlimited odd numbers. So each and every example has something in common in these examples, so they form a collection. So these collections having a common property of future is known as a set. Set means a well defined objects or numericals is form a set. Here examples given seen so far, collections of something having common. So we can say a well defined collection of objects or ideas is a set. Here we have to know the term well defined. What is well defined? Well defined means it says the objects in the set having a common feature or a property, and it holds another characteristic also, that we can say whether an object belongs to it or does not belong to it. That is called well defined. Well defined holds two characteristics. One is the whole collection having a common property or a feature, and we can say any object that belongs to given set or not. That is well defined. In mathematics we come across so many collections that are natural numbers, whole numbers, prime numbers, factors of a particular number, multiples of a particular number, and coordinates in a plane. So these are all collections are known as sets in mathematics. So let's know third concept, naming of a. Okay, let us understand the term well defined by an example. Here I take a set A is consist of 2, 4, 6, 8, so on. Can you observe what are these numbers? Yes, these numbers are even numbers. So these numbers contain property that even. When I bring a number 3 to it, can I place it in it? No, exactly not, because 3 is not an even number. When I take 20, can I insert in it? Yes, exactly. 20 is in that set because 20 is an even number. So a set should fulfill the two conditions. One is a common property, and second one is it should be possible to say whether it is in it or not. So here set A is a well defined set because it it holds a common property even numbers, and we can say any number belongs to it or not. Only even number will in it, and rest of all numbers, that means odd numbers, not in it simply. So that is well defined. So now let us know naming of a set. Yes, naming of a set. We usually denote a set by uppercase letters of English alphabet X, Y, Z, A, B, C, so on. Here some examples of sets in mathematics are given below. The set of natural numbers is denoted by N. The set of integers is denoted by Z, and the set of rational numbers is denoted by Q, and the set of real numbers is denoted by R. These are the some examples of sets in mathematics. Okay, let's go to know types of sets. Yes, there are different ways of which which we can write sets. Basically, there are two. One is list form, and the other one is schedule form. List form is also called as roster form. For example, suppose we have the set of all vowel letters in English alphabet. We can write this set in two ways. That is, one is V equal to A E I O U. This way of representing set is known as roster form. Here we write down all the elements of the set within the curly brackets. In this writing of set, the elements are basically separated by commas. So this type of writing is known as roster form or list form. There is another type of represent set is known as set builder form. That is, we can write this set is in set builder form. That is, V equal to X as that X is a vowel letter from English alphabet, or X as that X is a vowel letter from English alphabet. In this way of writing, we use a symbol X or any other letter from English alphabet. This is followed by a semicolon or vertical line, after which we can write common characteristic property posted by all the elements in that set. This way of writing is known as set builder form of set. In this form, we cannot write all the list like above, but this whole the letters enclosed are between the curly or chain brackets. These are the two various types of forms of a set. One is list form or roster form. Second one is set builder form. Okay, now we have to learn and another term which belongs to set is cardinal number. What is cardinal number means? The number of elements in a set is known as cardinal number of that set. For example, my set V is set of AEIOU. Here we find 5 letters. So, cardinal number of this set V is 5. That we can write it in n of V equal to 5. So, I take another set A equal to set of 2, 3, 5, 7, set closed. Here you see these are the first 4 prime numbers. So, cardinal number of set A is 4. We write it as n of A equal to 4. Okay. Here we have to keen observe a thing, that is, while list down the elements in a particular set, if an element is repeated more than one time, we have to treat it as one element. For suppose I take my set A is set of 1, 2, 3, 4 and 3, 2. Here you observe 2 and 3 are repeated 2 times. So cardinal of this set is n of a equal to not equal to 6. Here n of a equal to should be equal to 4 only, because 2 and 3 elements are repeated again. So you have to remember that particular thing. And one more thing is, while writing list form of a set, the order of elements is immaterial. For suppose we can write A is set of 1, 2, 3, 4 as A is set of 4, 3, 2, 1, A is set of 1, 2, 4, 3, A is set of 2, 1, 3, 4. So we can write A equal to set of 1, 2, 3, 4 in 24 types. So when we change the order of elements in a set, doesn't change that particular set. So that gives same set, but elements are changed in order only. So while writing list form of a set, we have to remember two things. No letter, no object shouldn't be repeated, and order of elements is immaterial. Okay, we go to exercise problems. So coming to problems in 2.1, question number 1, which of the following are sets? Justify your answer. Question number 1, the collection of all months of a year beginning with the letter J. Yes, it is well defined, we know. Who can write? The set is the same. So we can easily write the months of year started with letter J. January, June, July. I take it as set M, set of January, June, July. It contains 3 elements. Coming to the next problem, the collection of 10 most talented writers of India. Collection of 10 most talented. What is the word here used? Most talented. What it means? So we can't determine it well. So the collection of 10 most talented writers of India, we cannot accurately define it. So it is not a set. So second one, it is not a set. It is not a set. It is not a set. Why it is not a set? It cannot be accurately defined, because what is meant by talented? Various people think various types of talent. So whether it is novel writing or story writing or cinema script or poems, it may be what talent. So we can't say accurately defined it talent, the term talented. So it is not a set. Now coming to third question, a team of 11 best cricket batsmen of the world. It cannot be accurately defined it also, because it is not a set. It is also not a set, because best means what is the best? As of my feeling, I write India's cricket batsmen. Someone write his own best. So various persons has their own best cricket batsmen, has their own feeling. So it is also not defined. So accurately, it cannot be accurately defined. So I write it is also not a set. So I write it is not a set. I write it is not a set. Coming to fourth question. Coming to collection of all boys in a class. Certainly we can count. Certainly we can write all the names of our class boys. So it is a set. It is a set. It is a set. It is set. I write it as set B. It is, for suppose there are only 3 members. One is Ravi, second one is Raju, third one is Shankar. These are only 3 boys in our class. So I write set B equal to set of Ravi, Raju and Shankar. So we can define it. Coming to fifth question in that post-Roman, the collection of all even integers. All even integers. Yes, we can write all even integers. So it is also right. So I can write it is a set. It is a set. I named it as E. So because it is even numbers, maybe we can denote by any other uppercase letter also. So I take it as E, and that -4, -2, 0, 2, 4, so on. So on. These are the elements of the set. So it is it has unlimited elements. This is the first round. Coming to second question. If A equal to set of 0, 2, 4, 6, B equal to set of 3, 5, 7, and C equal to set of PQR, then fill the appropriate symbol belongs to or does not belong to in the blanks. We know the symbol belongs to. This is belongs to. This is the letter from Greek alphabet. It is called as epsilon. We use it to denote belongs to. This means belongs to. Belongs to. Which means whether the element is placed in that set, we can write belongs to. When the given element is not in that set, we write does not belong to. So coming to question, 0 dash A. Yes, 0 is in A. So we can write 0 belongs to A. Here 3 dash C. Yes, 3 is not in set C. So we write 3 does not belong to C. Like that we can complete that Roman number. Coming to third question, express the following statements using symbols. Express the following statements using symbol. First question, the elements X does not belong to A. Yes, does not belong to. So X does not belong to A. Here we use a symbol like this. D is an element of the set. D is in that set. So we write belongs to. D belongs to B. 1 belongs to set of natural numbers. So 1 belongs to, we use the symbol epsilon and N. 1 belongs to N. 8 does not belong to. So we write epsilon and cross it. 8 does not belong to P. Coming to fourth question, state whether the following statements are true, false, just your answer. True. Whether they are true or false. We have to say whether true or false. Coming to question 1, 5 does not set of prime numbers. Yes, 5 is a prime number. 2, 3, 5, 7, 11, 13. These are all prime numbers. So 5 is placed in prime set. But here does not. So it is a false statement. And S equal set of 5, 6, 7 implies 8 belongs to S. Clearly 8 is not in this set. So 8 belongs to E. It says 8 belongs to S. So it is false statement again. 5 minus 5 does not belongs to W. Yes, W is denoted as whole numbers. So whole number does not contain negative numbers. So it is a right statement. So we write true. And 8 by 11 belongs to Z. 8 by 11 is a rational number because it is in the P by Q form. It is not in Z. Z is set of integers. So it is false statement. Coming to fifth question, write the following sets in roster form. Yes, now we coming to forms of a set. And we have to list out all the elements containing this set. B is set of X, is that X is a natural number smaller than 6. Smaller than 6. So B is set of 1, 2, 3, 4, 5. These are the smaller than 6. Okay, it completed. Coming to second question, C is set of X, is that X is a 2-digit natural number such that the sum of its digit is 8. Sum of its digit is 8. It to be a 2-digit, not only that sum of digits is 8. So I write here question number 5 in that 2 is C is set of, I start with 1, so 178. So it is double digit and sum of digits is 8 and 2 6 and 3 5 and 4 4 and 5 3 and 6 2 and 7 1 and 8 0. These are the 2-digit numbers. Sum of digits is 8. So my set contains 17, 26, 35, 44, 53, 62, 71, 80. Like that you completed that Roman. Coming to sixth question, write the following sets in set builder form. Set builder form. That means here we have to find out the common property in that elements. So coming to first question, set of 3, 6, 9, 12. Yes, we clearly say that these are the multiples of 3 up to 4. That means are multiples of 3 less than 13. So I write, I take it as a set A. So every element in that set X that belongs to multiple of 3 less than 13. And we can write in another way also, that is A equal to set of x that x equal to in 3n form, where n is less than or equal to 4 and n take from natural numbers. So here we get n is natural number and that is less than or equal to 4. So 3 1s are 3, 3 2s are 6, 3 3s are 9, 3 4s are 12. Enough. So we can complete this list form to turn into Scertmaths form. Coming to another question, 2, 4, 8, 16, 32. 2, 4, 8, 16, 32. Yes, these are the even numbers. Not only it possessing another property that are these are the powers of 2, power numbers of 2. So these we can get by 2 for 1, 2 square, 2 cube, 2 for 4, 2 for 5. So I write the set here, B equal to x as at x. X is power number of 2, where n is less than or equal to 5, and take that power number from natural number. Take that power number from natural number. This is the Scertmaths form of that given elements. So we can replace n below 5, 2 for 1, 2, 2 square 4, 2 cube 8, 2 for 4, 16, 2 for 5, 32. So up to 5. So our set is completed. Like that, we can write all the list form into Scertmaths form. And another two problems are there, 7th and 8th problem. These are very simple problems. I gave them to you. Homework. Do it at your home. Okay. Thank you for watching. Share it to your friends.